See what we have a capacitor and an inductor, correct? So let's say a charge of q coulombs is passing, all right, and let the capacitance be C, the inductance be L. Okay, now what we have here is, as the charges keeps on flowing, we have the change in current, correct? So we have di by dt, correct? Now see, the induced EMF across the inductor will be minus L di by dt. We have learned this, right? And the potential difference across the capacitor, that will be Q divided by C, correct? Now see, by Kirchhoff's law, Kirchhoff's voltage law we are taking, the net voltage should be 0, correct? So we have minus L di by dt plus Q by C is equal to 0, correct? So we have L di by dt minus Q by C is equal to 0. Okay, see, in the present case what we have, the charge on the capacitor decreases, correct? So as the charge in the capacitor decreases, the current will increase, because discharging current will increase, correct? So what we have is I is equal to minus dq by dt, because there is a decrease in the charge, so we are taking negative. All right, so we have I is equal to minus dq by dt. So di by dt is equal to minus d square q by dt square, correct? So what we do is we substitute I using this value. Okay, so in the previous case what we have di by dt, correct? So the equation reduces to minus L d square q by dt square minus q by c is equal to 0. So far understood, right? Okay, so having said that, so what we have is, we divide the whole equation by L. Okay, and we also have a negative sign, so take off the negative sign also. So we have d square q by dt square plus 1 over LC into q is equal to 0, correct? See what we got here. So we got an equation in terms of d square q by dt square, right? Okay, see, let's say whatever the frequency of the oscillations you have, let's call it as omega. Okay, then what we have, 1 over LC will be omega square, correct? Because you have learned that in resonance, correct? So what will happen to the equation? You will get d square q by dt square plus omega square q is equal to 0, correct? So far understood? So what we got is a differential equation, so of second order. Okay, so we have a differential equation, so we need to solve the differential equation to get the particular solution. All right, so what we get is, we compare the same equation with the mechanical form. That is, when you take a spring, when you stretch the spring and when you leave it, so that also forms an oscillation, correct? So we compare this LC oscillation or the electrical oscillation with the mechanical oscillation, and then we actually deduce few results. Okay, so you will be seeing one table. So if you look at the table, you will see the comparison between electrical oscillation and mechanical oscillation. All right, so I hope you guys are clear with the difference between these two. All right.